Today we're going to talk about measuring resistors. The most important thing is getting an accurate resistor measurement. So we'll show a couple of the things that can go wrong and how to avoid those problems. We'll make the assumption that you're using a standard meter like this. And it's inexpensive, fairly accurate, it's old, it auto ranges. So what we'll do is we'll set it to ohms. The resistors we're showing you now are the standard metal film quarter watt 1% resistors that make up most of what you'll see in the Akatika kits. There are some other resistors that can dissipate a bit higher power. Those are 2.2 ohm resistors, and they're rated at a watt or two, I forget exactly which. And then we even have some larger resistors, and those are 0.33 ohms and rated at 3 watts. And then kind of at the whole other end of the spectrum, here's a bit of a new product. It's a surface mount resistor, and actually as surface mount resistors go, it's a fairly large one. There's a new kit coming up that will have that. So the first sanity check is if you have ohms selected and the two probes are not touching, the meter should say OF or OL. Either one is an indication of overflow, and it varies from meter to meter. And the other sanity check that you can do is if you touch the two probes together, you should get a reading kind of close to 0 ohms. And in the case of this meter, we're getting pretty darn close to 0 ohms. That's pretty good. What we'll know is that we have to take off a little bit of resistance if we saw it there. For example, if your meter had a, quote, 0 that was 10 ohms or a few tenths of an ohm, you would subtract that from the total reading. So anyway, let us now measure this resistor. And that resistor says it is 1.498 kiloohms. If you look in the lower corner of the display, lower right corner, I guess that is, you'll see 1.498 and then the kiloohms. So it's about 1500 ohms. And the color code of the resistor actually says that this should be a 1500 ohm resistor. We'll talk about color code, but not right now. Now you'll notice that when I measured the resistors, special pains, or I took special pains not to touch the probes. And the reason is because the body itself has some resistance, and that can corrupt the measurement of a high value resistor if you had your fingers across the probes. Now, there we're seeing that my body resistance is about 15 or 16 megohms. That's pretty high, but still that would cause about a 5 or a 6% error if we were measuring something like a 1 megohm resistor. And we definitely do have 1 megohm resistors. The other thing we can do is, it was off camera when I did it, but I licked both of my thumbs. And what that does is it should drop the body resistance considerably. And now the resistance across my body is about a megohm, about 15 times lower resistance than we had. So in summary, the one thing you want to do is you'd like to make sure that your hands are dry, and the other thing is that really you do not get your hands across the resistance. Now what we're going to do is look at another kind of meter that's out there and another way that you can get some results that don't really make any sense. Now we're changing over to a different meter. This is an old fluke meter. It's a very good meter. And we do our first sanity check, and we see that with both probes not touching, we have an overload condition or an overrange condition. Let's go measure a resistor and see what happens. Now this is the same 1500 ohm resistor we were measuring previously. And it still says overload. Well, that's really strange. So we have to think for a second, what is it that's hurting us? Well, this one is not an overranging meter. So what we have to do is we have to make sure that we are on a range that would include the measured value. So we've changed from the 200 ohm range to the 2000 ohm range. And now we see it's about 1.499 K, which is pretty good. And this meter does have one other great trick. If you're interested in zeroing the meter, notice there's a little residual left on this range. Not much. We can push the relative button and that subtracts the residual. For the last resistor that we talk about today, We're going to use a big one. This is a 4 ohm resistor. It's rated for either 50 or 100 watts. This is the kind of resistor that's used when you're measuring amplifiers and checking their output power, that they can deliver rated power into 4 ohms or 8 ohms, depending on how you might configure a couple of these guys. So to measure him, well, let's start out with a quick sanity check. We see the 2 probes are not touching. We have an OL condition. That's good. We touch the 2 probes together. There's a little bit of residual, and we can take that out with a relative button. And now we'll measure this particular resistor. And actually I can cheat and I can put my fingers across, because this is about 4 ohms. So a megohm in parallel with 4 ohms is no problem at all. And we see that this particular resistor is about 3.99 ohms, which is really quite close to the rated 4 ohms. That pretty well concludes what we need to talk about today for the art of measuring resistors and getting good and accurate results. The next time we get together, we may look at resistors in terms of how they're specified and the value ranges they come in, the power ranges, and even some of the characteristics of the various resistor types, so you can pick the right resistor for your next project.